Hi there, this is Penelope. This is the second video in a series of short videos just with examples of solving trig equations. So this is number 2. Now, we're looking here at slightly more practical examples of solving them, so we're not just solving them for the sake of solving them. What you've got to do when you've got a question that's practical, you really have to find the function that you're talking about, so there it is there, and then just identify the questions, because there's a lot of writing there, so you just need to work out what it is that you're looking for. There's a third question on the next slide. So the maximum number of amps is just the amplitude of the function, and if you look at that, the maximum is 10 amps. Question then goes on to say the current's been turned off for exactly 0.1. Now that says that t equals 0.1 second, and we have to find the current when it is t equals 0.1. So I'm just going to substitute that in, making sure your calculator is in radians. Okay, just use your calculators and you will find that A is approximately equal to 0. The third question was, how long does it take for the current to change direction after it's been turned on? Now this is the question. If it's going to change direction, it's going that way and then it's going that way. So very briefly, it's got to be stopped. It's got to be 0. So at the very point that it's changing direction, A equals 0. So we just have to solve that. So we've got 10 sine 120 pi t equals 0, and we have to solve for t. So dividing both sides by 10, taking the inverse sine of each side, and that will give us that 120 pi t equals, now inverse sine of 0 is 0 or pi, and having the answer as 0 doesn't really make much sense at the moment, so we'll ignore that and we'll look at the answer when it's pi. So t equals pi divided by 120 pi, which is 1 over 120 seconds, and you might need to put that into milliseconds. The next question again is a practical one, and again there's a lot of writing, but what we need to do is we need to highlight the function. There it is there, and then we need to look at the questions, and there's a question and there's a question, so it doesn't need that there. So for how long does the pump inhale each time? What we've got then is that when R is equal to 0, the pump stops inhaling. Just briefly. So we have to solve 0 equals 2000 sine pi t over 4, and again I'm just going to make myself a little more room. So taking inverse sine of each side, and that means that pi t over 4 equals 0 or pi. And again, 0 doesn't make much sense, so we're just going to say pi t over 4 equals pi, so therefore t is equal to 4 seconds. And if you look at the graph, there's 10, so that's 2, 4, 6, 8, 10. So there's the 4 seconds there. So that's where it's come back to being 0. It's obviously 0 when t equals 0, but it's also when t is equal to 4, then the r is equal to 0. Now, when does the rate of change of air pressure first exceed 1500? Well, that's what we're going to do. 1500, we're going to solve that, is equal to 2000 and again we need to take the inverse sign, so we're going to divide both sides by 2000, so I get 3 over 4 and that means that sine inverse of 3 over 4 equals pi t over 4. Sine inverse of 3 over 4 is 0.848 or pi minus 0.848. Now I'm just going to run out of room there. Do the calculator, multiply by 4 and add the number, work that one out there. So that will give you that t is equal to about 1.08 seconds, or from the second answer, t is equal to approximately 2.92 seconds. And if you were to have a look at the graph, there's the line 1500, so there and there are the amounts. So the 1.08 is when it's first exceeded it, and the 2.92 is when it's exceeded it, coming down on the other side. Okay.